Now let's take a look at how to solve logarithmic equations. So there are the equations that we have logarithmic expression in both sides of the equation or in only one side of the equation. So if the bases are same on both sides of the equation in the logarithms, then we can directly equalize numbers written beside logs to each other. But the questions are not always that simple. We have to do more work. Let's take a look at some examples and see what kind of work we should do. So first question, solve for x. Log base 3 of x minus 5 equals 2. So there are two techniques here. We can just use the method that we already learned in section 3, converting logarithms to exponents. First way, how do we convert logarithm to exponent? Remember, we use the same base, 3, raise 3 to 2, and equalize it to x minus 5. Remember, start with the base, go to the other side, and come back. You follow this rotation. 3 squared equals x minus 5. 3 squared is 9. 9 is x minus 5. Bring negative 5 to the other side. So x becomes 14. That's a way. Another way is using inverse property that we studied in the previous section. What does the inverse property say? Remember, if there is b raised to power log base b of x, then we can cancel the bases. Base of the exponent and the log base b will be cancel each other. They will be cancelled. We will left with x. So we use the same property here. We use 3 as a base in both sides. So 3 raised to power log base 3 of x minus 5 equals 3 to the power of 2. So these bases will cancel each other. 3 and the log base 3 will cancel each other. We will left with x minus 5. X minus 5 is 3 squared, which is 9. Bring negative 5 over. X is equal to 14. The same result. It doesn't matter what method you use, you'll get the same answer. So part B, there is a scary looking equation, but it is not as complicated as it looks. We just have to write these logarithms as a single logarithm that we already studied this in the previous section, right? We know what subtraction means, we know what addition means. We studied this before, so we will use the same techniques. If there is subtraction here, it means log base something minus log base something else equals log of quotient of two things. Remember, we have the same bases. There is subtraction here, which means log base 10, the same base of the quotient of these numbers, 45x divided by 3. So I just have to write one logarithm alone on one side of equation to simplify the logarithms. So that's what we have on the left. On the right, I have 1. Just simplify what we have here. 45 divided by 3 makes 15x equals 1. So after this step, everything is same. You either apply the first way or the second way, you get the answer. So I will stick with one way only, not to confuse. I will use the inverse method. What is the base here? Our base is 10. So I will exponentiate with a base 10. Both sides will be exponentiated with base 10. So in this case, base 10 and the log base 10 will cancel each other. I will left with 15x on the left. On the right, 10 to the power of 1, 10. Divide both sides by 15. X is 10 over 15. Or I can write this as decimal. It will be approximately 0 point something. All right. Let's continue with C. Part C, we have only one logarithm here. First thing I need to do here is I see an exponent. Let's get rid of the exponent. Let's make it a little bit simpler. So exponent can be brought out in front. So write this as 2 times log base 4 of x equals 7. Let's divide both sides by 2. So log base 4 of x equals 7 over 2. Now it is simpler. I will apply this inverse property here. I will exponentiate both sides by using 10 base 4. So 4 and the log base 4 will cancel each other. I will left with x on the left, on the right, 4 to the power of 7 over 2. So you can use your calculators, type your calculator 4 to the power of, in a parenthesis, 7 divided by 2. It is a way, but don't forget to use this parenthesis. You will make a huge mistake if you don't. That's a way. Another way, you can simplify it by hand. 4 is equal to 2 squared. So replace your 4 with 2 squared. 2 squared to the power of 7 over 2, right? So now I have 2 at the top, 2 at the bottom. They will cancel each other. I will left with 2 to the 7. What is 2 to the 7? Let's calculate this. It is going to be 128. So this is the way of solving logarithmic equations. Hi guys, in this video we will be learning about exponential and logarithmic equations. We will be studying two different techniques here. So the first technique is write everything we see in terms of one fixed base. So expressing each side with the same base will help us to solve the equation. If we have the same base in both sides, then we just have to set exponents equal to each other and we will find our answer. This is the first technique. The second technique that we're going to use is taking the logarithm of both sides. So by doing so, we will equalize the numbers written, the expressions written right beside logs equal to each other. So let's start solving the questions. The first question, we have exponents in both sides of the equation. So the first thing we need to do is try to get the same base. So express each side with the same base. Can I write 8 in terms of 2? Yes, I can. 8 is equivalent to 2 cubed. So just write 2 cubed for 8. So 2 cubed raised to power x equals 2 to the power of x plus 6. So remember, if there is an exponent raised to another exponent, we multiply those two exponents. So 2 raised to power 3 by x, 3x equals 2 raised to power x plus 6. So now, since the bases on either side of the equation are same, then the only way these can be equal is if the exponents are equal to each other. So exponent on the left is 3x, exponent on the right is x plus 6. When I set them equal to each other, I will solve my equation. Bring x to the other side, it makes 2x. 2x is equal to 6. Dividing both sides by 2, x becomes 3. So that's my answer. It's pretty simple. What about part B? In this question, can I write 200 in terms of 5? Let's check. You can use your calculators, try and see if 200 is a power of 5. 5 to the first is 5. 5 squared is 25. 5 cubed is 125. 5 to the 4 is 625. So I don't get 200. I can't write 200 in terms of 5. So the first property doesn't work here. I'm going to apply the second property. The second property says take logarithm of both sides. So write this as log 5 to the power of x minus 2 equals log of 200. So since I am not writing any base here, which means I am using a common logarithm here, the invisible base is 10. Let's remember section 4. We have a power here in the logarithm. Then we can bring this power down in front. So exponent can be brought out in front, which becomes a coefficient. So x minus 2, this is a quantity that I have to multiply by log 5. So I need to use parentheses. X minus 2 times log 5 equals log 200. I need x alone, so divide both sides by log 5. Divide both sides by log 5. So x minus 2 equals log 200 divided by log 5. Here in this case, we can use our calculators. Everyone has this calculator in the bottom, log base 10 of something. So just type this, log 200, and type log 5 too, and see what the answer is.